Within triangles, let's look at this very, very beautiful problem. We have this triangle, and I'm going to try to label everything counterclockwise. And we have some point here. Let's call it O. You can call it anything. And from O, we draw parallel lines, lines that are parallel to the sides. So this line parallel to this side is B, this side is A, this side is C according to classical conventions. And we draw parallel to this, and now draw parallel to C. So we have these little triangles, triangles within triangles. Okay. And let's label these points. EF, GH, again, counterclockwise this way, just so that we have some sense of direction. It's so easy to get lost in these geometry figures. GH, IJ. Now the question is this, is if S is the area of the big triangle ABC, then and S1, S2, and S3 are the areas of small triangles. Okay. Then the question is, what is S in terms of S1, S2, S3? What is S? Can you express S in terms of this? And yeah, you can. The answer is really astonishing. First, we need a little theorem. We have this little triangle and a big triangle, and we say that they're similar. And this is side A, B, C. Let's say this is A prime, B prime, C prime. Then the area of triangle 1, triangle 2, area of triangle 1 over area of triangle 2 is A over A prime all squared, equals B over B prime all squared, by similar triangles. Now, first job for you is prove this. It's not hard to prove. I'm sure you can do it. It's just similar triangles, and triangle area formula should be pretty easy. Now let's apply that to here. Let's look at this carefully. First of all, this triangle is similar to the big triangle, okay? Because this angle is the same as this angle. This angle is the same as this angle, and this angle is the same as the B angle. Okay, so I right away I have S1 over S. Let's call this area S1, and this area area of this triangle S2, and this one S3. So S1 over S, well, it's this side B, and here EF. So this is equal to EF squared over B squared, according to this concept here, okay? The ratio of the triangle areas is the square of the ratio of their sides. Now, S2 over S, what's S2 over S? Well, I'm not going to use this side. I'm going to use this side because there's a special magic thing involved here. GO is the same as FA by properties of parallel lines. So it's AF squared over B. This way I can keep the same denominator, B squared, okay? S3 over S, what's that? Again, I'm not going to work on this side here. I'm going to work with this, which is exactly the same as this. Here to here is the same as here to here because of parallel lines. Everything here parallel. So that's CE squared over B squared. Let's add them up. S1, let's add the square roots of these things. S1 over S square root is EF over B, and S2 over S square root is AF over B, and square root S3 over S is CE over B. Okay, take the square roots. Now, add them all together. So I have square root S1 over S plus square root S2 over S plus square root S3 over S. This is equal to, watch this, EF plus AF plus CE divided by B. Now, what is EF plus AF plus CE? Let's go back to our figure. EF plus AF plus CE, yes, that's equal to B. So this, in fact, is B over B, which is 1. So now let me factor out 1 over square root S. I have square root S1 plus square root S2 plus square root S3 is 1. And therefore S, triangle area of big triangle, is this absolutely beautiful expression. You like that? Beautiful, beautiful. Now, you're probably thinking something like this. What if I would have started on this side? Yes, indeed. Why don't you try? Use this identity, Cj plus Ji plus Ib equals A. Or use this identity, Ag plus GH plus HB plus HB equals, hang on, my board is moving around, plus HB equals C here. Use this identity, okay? We don't have to use this one, EF. That just happens to be the side that I chose to work with. This one is the one I chose to work with, but you can try it with this one or this one, why not? And as an exercise, why don't you do it? Try it. Okay, this was a competition problem from long, long ago. Exceptionally beautiful in every aspect. Okay, can you imagine a more fantastical answer than that? Beautiful. Okay, if you like this, then click like on the vid and subscribe for more interesting problems.